Welcome back, everyone. Today we're working on one of our first practical, actual real-life labs. So what we want to do, what our job is today, is to model this NEMA 24 bipolar stepper motor. So our stepper motors are used throughout industry. They're in our CNC machines, a lot of our robot devices, automation, etc. And so if we're going to build a part, if we're going to build a conveyor belt, let's say, a real simple type of a mechanism, I need to have a motor on there, and maybe there is a sensor that says when product reaches a certain amount, start and or stop the conveyor belt. So it's a little bit of an automated device. And in a lot of these situations, we're going to use a motor like this. Now, the reason we need to model this, we're going to buy it, we're not going to build it, right? But the reason we need to model it is so that we can get our size and scale right for, say, the rest of the frame of the device that we're making. And so that becomes very, very important. So what we're going to do today is we're going to model this up, even though it is an assembly. This here is a part this is an assembly of many parts. We're not going to worry about that. We're going to make a simple, solid, single mesh model that we can use to bring into our part for size and scaling. We're going to make it maybe a little bit more complex than you would possibly need it to be to suit your purpose for making the frame, but it is a CATIA lab, so we want to kind of dig in just a touch. So just know that even though looking at this right here, those fasteners, yeah, those are fasteners, those are parts by themselves. This cap actually comes off, and so does the one in the back, and so that's, you know, at least 3 more parts right there. The stator, or the magnet, so to speak, that running through the middle, it goes inside there, separate part, and more on the inside there. So no, we're not going to do that. We're not going to do that. We're just going to get kind of the idea. Now, to help us along the way, this is the biggest of deals here, is that you can build a part from a data sheet. So here is the data sheet for that specific stepper motor, and it does give you the dimensions that we'll need to serve our purpose, to build our frame, if we were to go so far. Now, a couple other things to think about as we get started with making this. Probably first thing is order of operations. Where do we start? You know, do we look at this and measure out a rectangle like this, and then we thicken it this amount? Do we make this square? Do we pad it out that much, that amount? How do we go about doing this? Now, the probably best answer here is that you're actually going to make the model a few times. So you got to get kind of used to that. If it's an important model and the tree structure over here actually ends up mattering to you and to other people you're working with, yeah, then you probably want to build it, kind of figure out how you're going to do it, and then stop and come back, right? So I'm sure we'll discuss that more along the way. Now we also have the actual model drawing, or the actual model over here, the image, so we could look at this and kind of get some inference as well. If even nothing else, color or, you know, kind of fasteners, how they look, this groove isn't quite exactly defined, so we might have to make it up. Doesn't really matter for what we need. So this being our first look into creating models from data sheets, we're not really going to dig into the nuances of this particular model too much, but you could do this 4, 5, 6 times and definitely, you know, get into every small detail. Then to get started, I feel like I want to go from this side and pad it out rather than go from a rectangle on this side and pad it out that direction. Why do I feel this way? I'm not really sure. I feel like I would be very disturbed to make it this way. And my best thought is that I like to deal with the symmetrical side first, or also I know that the NEMA 24 standard has to do with this mount right here, but sometimes the motors are longer or shorter than others, but they have the same mounting pattern. So I would like to go with this as the sketch facing forward, and then if I need to, I can easily change the pad length rather than having to get into the sketch that made it and changing it. Maybe there's something going on there in my head. But we'll go ahead and we'll start from here. So we look at this and we see that we have 60 millimeters, right? And then we're going to have a unit down here somewhere that'll say what it's in, but you know, it's from China, so it's going to be millimeters. And you know, plus or minus 0.5. Now that's not for us, that's for the shop, of course, right? They're just saying that when you buy these things, just know that it might deviate by this much. Then if how this part fits into your larger product greatly matters, and this plus or minus half a millimeter is critical, you might want to model this part that we're making here at 60.5 instead of 60, just so that you make it the biggest that it could possibly be, if that's the case, or smallest, right? We're just going to go with 60. So we'll keep this off to the side, and then we'll refer back and forth between this and our actual drawing, our actual model here. I feel like I want to choose this plane. You don't have to. So I'll pick that, and I'll go with a centered rectangle right in the middle here, and pick this edge, click on the background, hit this one so that the contextual menu comes out, click, make it 60, and then do the same for right here. This would be good to turn into a parameter if you needed it to be. Now this also, if we go back to the part here, it has rounded edges. Now I don't see it calling out what they are. We're gonna have to make some guesses on this, and this is absolutely fine for this situation. Do we want to do this in the sketch? Well, it would be very typically, usually more beneficial to make it as a fillet on the outside, because the fillet will show up here in the tree, and we can see that. A corner in a sketch, well, it's another thing we have to find. We've got to dig the part bodies or the pads and the pockets out to try to find the right sketch. We could turn it into a parameter, and then maybe it doesn't matter. But again, typically, classically, the fillet is better. But just to show you, since we don't usually mess with this terribly too much, here's the corner tool. And if I did want to add it in here, I could bring this in. Now notice up in the top left corner, I can't see right here. Don't look at what I'm doing here. Look at this menu right here. We have a lot of different options. I don't want to go through those all right now, but if you look at it a lot or test it, go make a square and try these out. It has the ability to make this corner and leave a construction element there, leave the actual lines there, break it, trim it, every option that you could think of. Okay. Now, by the way, that error that popped up is a very interesting thing. It popped up because it says it's impossible to trim a lengthened element. Would you like to turn it into a distance? And what it was meaning there is that I chose this line to be this dimension right here, which you would think would be the obvious way to do it. Okay, I'm going to undo some of this just to show you. After using programs like Fusion 360 and others, I start to kind of slack and lose some of my, I guess maybe you'd say, good habits. Is it a good habit? I don't know. You tell me. But it's been taught in many courses that you don't just grab this line and measure that and make it be 60, because you're technically measuring this line and not this line. But because of the vertical constraints in the horizontal and the symmetry of the centered rectangle, it will be the same, right? But what they say that you should do is pick this line to this line. So now I've created a distance between this line to this line instead of a length of a line. I know that says length, but that's the way that it looks at it. So if I go 60 here, and then I go from here to here, and say 60, now when I put that corner in there, I won't get the error. So I pick these two corners, or you can pick the point. See, then it just drops out, and that's all fine. Okay. The thing it was doing was adding in a little point right out here in the corner, and saying that this fillet exists, but this 60 millimeters is a point that is constrained to this line and to this line right there. Right. Go ahead and do that on your own if you want to see that. Now, I do have to talk about geometrical and dimensional constraints as well. So we've got our geometrical constraints. They were on, but the dimensional constraints were not on. So something did not happen right here. So I got to show you that as well. Okay. So I will open this up, and I'm going to turn on. It's a toggle. It's on or on. It's on or off, and it stays on or off, right? Even when you close and open the program. So dimensional constraints is now on, and so is geometrical constraints. So if I go here and I draw my fillet from corner to corner here, the corner, and I bring it in, Now it includes a dimension, and you see it's green now because it's still fully constrained. So is that more beneficial to you? In this particular case, I think it probably is, so you would leave those on. Okay, so that's another little insight to what those things are about. Now I can come in here and I can say maybe it's 10, and then I go through and I do the corners on each side. And just to show you, I could grab the point there and I could bring that out, same deal. Okay, make this one equal to the other ones, or just by hand go here and say 12, 12, 10, 10, oh, 10. Okay, now I'm just going to leave it there for a second. I want to exit out of here, and we'll pad this up. I don't really care about how far I make this right now, because I just want to show you about the use of either the fillet or the corner in the sketch. So we put the corners on here, and then I go back to my diagram and I look and I try to determine what this radius should be. It does appear to that this might be concentric with that circle, maybe, maybe not. I don't think it quite is, but anyways, we got to kind of make a guess what it looks like, you know. And in this case, yeah, it's probably pretty close to that. But let's say I didn't like it, I want to change it. Well, I've got to know where to go to do this. Now imagine also we've got more items in the tree. I can click on this, it will show me the pad, I can hit the plus sign here, and I know that it's going to be in that sketch most likely. But that's if you know that this is actually a corner. You're gonna spend the first couple minutes looking for a fillet. Honestly, again, you can click on it, it'll highlight where it is in the tree, and then you'll find it. You see? So it's not a big deal, right? Kind of. But now if I want to change it, I have to change each one. 12, 12, 12, 12, 12, around there. Okay? I could make them be a perimeter, and again, it would be fine. But kind of typically, simply, it's going to be probably in your best interests to leave it just like this. You also have the benefit of having a simpler sketch, and that's a big concept in itself, is to simplify the sketches that you're creating. Don't put too many features in there. It's a kind of a good way to think too. It takes a little bit to, you know, stop looking at a diagram and draw every hole, every corner, everything, every circle, and try to do it all at once. Try to break this down into multiple sketches in your mind before you start. So I look at this and go, you know what? Just a sketch first, just a square, just a square. So we'll go ahead and we'll do that, and then we'll pad that up some length. Okay, and again, I'm just going to leave this at some value here just to demonstrate the fillet principle, I guess. And then we come by here, we grab our fillet, and then I can pick this edge, this edge, this edge, and you can see already in the tree, it's over there. I can say that this is 10, and now if I want to change this because it doesn't quite look right, then I could double click this and say, no, I want them all to be 12, they all change, you see? So that's usually the better option. Okay, so then what next? What next? We look at this. So this is rounded and it extends out all the way down here. But let's look at the real part. We got to look at the real part again here and see how this works. You can tell that this is a flange, and this is used to mount the device to the casing of the, you know, wherever this is, whatever it's supposed to be driving. This curvature here, does this continue? Obviously, it's a cavity here, but is this flush? Yeah, it does appear to be flush. Is this flush? Now, these things right here, these are laminated pieces of metal. We're not going to model all of those, so don't worry about the fact that there's a little step here and there's a little weld that's running down the side here. Don't worry about that stuff. So here's my point. If I were to take this feature here and pad it all the way out to the back of this body here, would that be okay? And then cut this feature out later? Or would it be better to pad this up just the thickness of the flange right here and then build the rest of this on top of it? It's kind of 50-50 in my mind right now. So what I think I want to do is, well, actually, if you look at this, it does kind of extend up a little bit more right there. But I'm going to go ahead and just make the flange for right now. I'm really kind of hesitant on that, and it's sort of a 50-50. So I look at the drawing here, and if we look right here, we can see the width of the flange is 6.8. Okay, so that's easy enough. We'll go back over here to the pad, and we say 6.8, and that's going to get us our flange thickness. At this point, I can see that edge fillet, it's just not so good. So let's make it be maybe 8. But again, the nice thing is, as long as we be focused on what is dependent on these features, we can come back at any time and change our edge fillet. Okay, so then which side is going to be the rest of the model? Well, let's see, we started on this plane. Let's continue over into this direction. So I'm going to pick on this face right there, go into sketch, and then let's go back to our data sheet and decide how far out we want to pad this. Well, it's got to go 88. So I think that's pretty obvious. Look around, see if there's any other determining factors. So 88 max, that's fine. We'll go with 88. But we have to take 88 and subtract it from here. You see? Subtract this from that. So that's cool. We could totally do that. Or we could have maybe CATIA do it for us in a couple different ways. One thing we could have done is made this feature on our original plane, the same one that we made our flange on, and then just extrude it, pad it right through our flange, and then we could just type 88, and then it's a nice even number. Because if we get a different type of motor in the future that is maybe, 93, 64, something like that, instead of just coming here and saying 64, we have to remember to subtract that. You see, I could definitely write this as an equation. So try to think about what is going to be, the smarter way for us to do that. Then to call back to some other stuff that we've looked at before, what I want to do in this case is I want to write a parameter. I want to write a couple parameters just to kind of put this out here a little bit more frequently. So I go here and I go over to my tools and I find my formula. And I'm going to make a new parameter of a type of a length, right? I hit this. Don't type again anything in there first. First hit new length, and now this is the one right here. So I'm going to call this what? What am I going to call this? Well, it's not going to be the body. It's actually going to be the flange length is what we want to put here. And we're going to make this be 6.8. You see? So that's the flange length, and you're going to see it right up here under your parameters. Okay, so I've just added that in there. Now what I can do, I can make another parameter for the body length, which would be a great thing to do. Right? So might as well do that. Right? So hit it here, and we'll say body length. Now we'll have to kind of understand and define these terms. There could be, your work documentation that explains what exactly each one of these names that you make up goes to. We'll go ahead and we'll just make that 88, and that might not seem terribly correct, right? But we're going to modify it. So here's what we're going to do. We are not going to put a centered rectangle in here, at least not quite yet. We're going to project these edges. We're going to project our edges right there, project them as construction elements. Did you catch what I did all there, right? Projected, then turn them into construction elements. Now I could make my rectangle if I wanted to, but I don't want to exactly. We're going to do a bit more constraints than maybe we need to do. So I'm going to go back to my sketch tools. I could draw a rectangle. I could surely do that, but watch what I want to do. I'm going to go here, and I could anchor to that point right there, which could be fine, but I don't think it is. There's going to be a reason for this I'm going to talk about. So I'm going to bring this out straight so it's blue, so we know that it's horizontal, and I'm going to bring it up here, and I'm going to snap it to that line, not to the point. Now I'm going to carry it out here, and then down to here, and if I want to snap to over there, I can surely do that because that's okay. It will make a constraint to that. See the circle right there? It's stuck over to there. Just know that's an automatic constraint. If you don't want that to happen, then remember, you see all the blue lines there? If I hold down shift, it stops doing that. But that was okay. I wanted that in this case. So I go here and I snap again to that yellow line. I go to here, bring this out. I'm snapping to that thing up at the top. Do I want that? Yep, that seems okay. Click, get over here to the other one. Now what if I didn't get it, right? No big deal. If I need it, I'll add it later. Get that up there, and then I'll snap to the original point. Okay, so we've got this shape going on. Do you see what I'm doing here? This is to talk about sketch simplification. Is this the way that I would always do this part? I don't know. As I do this, as I'm making this lesson, this lab, and going through this part, I've made this part a few different times now. Actually, multitudes of times over the years because we build CNC machines and I've had to model separate motors quite frequently. Do I do it the same way every time? Probably not, just because it's not the ultimate decision on the best way that you do it. It's like, works good for now. Just start clicking, you see? So if we go back over here to this, I want to talk about model simplification. So in this case, this seems like a really good way to do it. I could have padded the whole thing up first, and then I could have just pocketed these holes down to here and left a little bit of a gap distance. We've done offset a little bit before. I could have made a circle up here, padded it all the way down to this bottom surface, but you're allowed an offset value, and so I could do a negative offset and say come back 6.8 millimeters. I could do that too, right? I think you could talk a long time about all the different ways you could do it, and you'll find out that, 8 out of the 20 ways are all perfectly fine, and it doesn't really matter. You just got to make a choice. So today, like I said, I want to talk about sketch simplification of sorts. So I'm not going to put the contours in here. We're going to do those as fillets in a second, but we make it as a simple square to start with, and it's a good way to start thinking about this. Now, to get these notches in here in the right way or where I want them, well, what's critical to me? Do I want this in, out, we got the points right there. It seems really close, If it's not, or you don't know it for certain, don't anchor it to the points at the corners, right? That's why I did not do that. So now I can go here, I can pick this, I can add a constraint, and I can say that is so far away from that edge line. So I'll say that it's 10. And then I'll take this one, and I'll do the same thing right there. I'll say that this distance right here is also 10. Now, I think it's probably a good idea to go here, hit equals, click on your background, and then select that parameter right there. We could actually make a parameter for this, of course, but what I kind of want to get going here is that I have this feature defined. Whatever this step in here, this notch is, I have it defined by one constraint, so I can change it, and they all change because they are all always going to be the same. And I'll go through and do the rest. Now, as I click on this, here's the thing that I think about as I do this. I start clicking around, and remember, you can't get to it from the other menu there. As I start clicking around, I start to notice that maybe this is taking a little bit of time. Right? Maybe this is being kind of long. Well, I could have left it as a solid even, and I could have made this one square as a pocket, and I could have patterned it around. I could have done a rectangular pattern. I could do two of these. I could do a mirror. I could do a mirror in Sketcher over here, or I could do a mirror of the solid that I make. So just tons and tons of different ways that you could do it. And this is why I'm saying that you make the model a few different times. As I make this, I keep thinking, man, for the class lab, I probably should have done it a different way. Let's do it a different way. Well, no, I just want to talk about, oops. I think it's better for me to just mention that there are a myriad of ways, and you would probably make your model over and over again if you wanted to try to determine what the best one is. I would honestly have to make this video like 10 different ways, 10 different times to show you all the different ways. Now, I can also say, did you notice as I was constraining these that some of them I didn't have to constrain all the way like this one? And that is because of the auto constraint that was made right here. So this, let's see, no, it was this one right here. This is even with this. And so if this is 10 and that's even with that, well, then I don't have to put a dimension out here. So knowing that kind of behavior, if I was a little bit more mindful of what I was snapping to when I was doing this, maybe I could have got away with, not having to do all of them, you see? So let's call this good. Again, many different ways to do this, but let's call that fine for right now. We'll exit out of here, and then we'll pad that up. Well, how far? Well, we're going to pad that sketch right there, right? And the length is going to be this body length, and you're probably going, yeah, but that doesn't include the flange length. I know. So we go edit formula, and so then what we do, we come over here and we say, okay, well, it's this parameter. You can go ahead and click it, but all the stuff that we make is under rename parameters. So you go to rename parameters, and we say it is body length, right? So we want to use body length, but then we're going to subtract whatever the flange length is. Do you see? You see what we're doing here? Then we hit OK, and then we're done. So now, anytime I come back here and I need to make a larger stepper motor and I look at the document, or somebody that isn't me that just walked up to this and says, oh, body length, I need to change that. You can come up here, you can change this to 96, and I can tell you that dimension right there is not 96, right? So if I measure from there, you gotta pick these to there, the distance is 89.2, right? So subtract that, 6.8, right? Okay, great. So then we'll come back to here and we'll probably end up modifying that curvature, that notch. You see, I didn't put a fillet on it yet. We'll deal with that later. It exists, but I need some context. So what I'm going to do next is I'm going to make these holes. So they're 47.14, 47.14. Make sure you look at this because there are a lot of things I deal with, the drone motors and some things are not always symmetrical, okay? So there are four of these at a diameter of 4.5 millimeters. Easy peasy. So we'll go over here to the face, we'll pick on this, go to sketch, and in this case we will draw a centered rectangle, bring this out, and then make it a construction element, right? And then we go to dimensions, and we're going to dimension this 47.14 was it, I think? Whoa, why did that just happen? And let me go check. 47.14. Okay, now I can make my circles. Make sure your construction elements are not on, and then we snap our circles to the points right there. Now, get ready to hold your shift button down. And by the way, if I double click circle, double click it so it'll stay on, I'll snap it. But now the more geometry I have in Sketcher, the more things you'll find that it wants to snap to. And I think you should probably develop a habit of holding down shift almost no matter what, if you're not certain that you need the constraint. So the first one, I know I needed it snapped there, but after that I hold down shift just to keep anything else from sticking to it. And notice, by the way, that I don't really care what size it is. You see, that's another thing to think about, is I'm holding down shift, I don't get the constraints, and then just make it as big as you need, because maybe that's going to make it easier to select later. A lot of times if you're trying to get it as close as it's probably going to be and then dimension it, there might be too many features around there that make it kind of hard to get a hold of, you see. Now I'll double click constraints so it stays on. I'll bring this out and I'm going to say 4.5, and then I can pick the next one. Oops, 4.5, the next one, 4.5, next one. All right, now you notice that these are all on radius, so that's kind of an oops, right? So it's not a radius, they're a diameter of 4.5. Oh, darn. Well, here's the thing. In some other videos, you might have noticed this before just on your own. I want to do a thing. I want to make these things equal to each other, or maybe I want to make a parameter for them. For whatever reason, they don't like diameter for parameters, right? So I could go here, let's go to tools here. I want to show you something. I like parameters better, but we do have this equivalent dimension feature right here. So we understand parameters, we've done this before, but this is maybe kind of a new thing. So it says, what things in this list here are equal to each other? Well, I'm going to edit the list, is what you got to do, and then you have to find them all, right? But if you click, they're going to pop up, kind of, sort of, you see? You could try to say, you know, pick the right one from here, but I can pretty much tell that it's 7, 8, and 9. But anyways, you could just do it like this. You move that one over. What's this one here? That one's 12. That one's 10. Yeah, good thing I didn't do what I was going to do, because that wouldn't have worked. 11. Okay, so now all of those are added in, and you hit OK, and it says, what do you want these things to be? Okay, well, I don't want them 4.5. I need them 2.25. You see? And now they'll be equal to each other. This happened, by the way, in a previous exercise where we want a dimension. So we've got the job done. They're all equal to each other. They're a radius, that's fine, except us humans looking at a data sheet, we want to change it to 4.5. We might not want to do the math. This might be a lot deeper decimal number than 4.5, and the math might be a little bit harder to do, or I just don't want to do it. So what you could do, again, what we did in previous lessons is we make a parameter, and it's the diameter, but this thing here is a formula, so it is half of whatever the diameter is. And so now that's easier, if that makes some sense, okay? I'm going to leave this one as it is right now because I just want to show off the equivalent dimensions feature in Sketcher. Okay, then we'll exit out and we will pocket these up to what? Up to last? Well, we're going to pocket them up to here. We could make it a dimension, right? 6.8, and that's what the flange is. That almost never makes sense, by the way. So many people do this, or they go, heck, just make it a million or whatever, right? Use these. Learn to use these. Up to plane, up to surface. It is a surface, but we're doing all of them. This is a surface. That's a different surface over here. So pick up to plane, and this will make an infinite plane for everybody to go up to, and no matter what, if we decide to change that flange length, that will change. Oh, by the way, our flange length right here, that's 6.8, we never associated it to our first pad. So let's fix that real quick. See this right here, 6.8, hit equals, click on the background, and now it's associated to that formula right there, that parameter. Right? So let me show you what I was talking about with the hole now. So if I make this, instead of 6.8 be 9, well, that right there is still going all the way through. Obviously, the flange changed size because we associate it, but also realize that this body length of, well, 96, I got to change that back to 88. The body length here is still 88. The total body length, because it always subtracts that flange from it. So let me show you with the dimensions again. Surface, surface, sure. Here to here, 88. You see? I don't need that there. Use your parameters. Get used to these things. They are pretty much mandatory once you start to get used to them. Okay, so we are kind of almost done. Kind of. So let's we see where these holes sit right here, right now, right? And so then we want to decide, do we want to pull this in or not? How do we want to deal with the fillets? Well, let's do the fillets first, because I can tell you that those are semi-arbitrary. They kind of don't exactly matter terribly too much. We just want to model it in just for looks, okay? So we'll leave it at 8 for right now. Pick here, pick there. Remember, you can turn on hidden edges if you don't want to have to rotate around. I find that turning them on and turning them back off is about equal to me just rotating the thing around. And then let's say 10 and see what that looks like. That's entirely too much, right? So we'll say 4. Okay. Might be a little bit more than that or a little bit less than that, but we'll see in a second. And now this one right in there, yeah, let's shrink these down just a little bit more. Make it 3. And by the way, very specifically, I'm making this fillet separate from these fillets because of the purpose, which is what I'm going to get to here in a second. So let's go ahead and just add it in, and then let's talk about that. So put these in, and we'll just make them, I don't know, be 4 or 5 or something. Okay, so what is the purpose of these grooves? Well, what you're going to attach the stepper motor to the body with is a socket head cap fastener screw, okay? So if you want to look this up, which would be the thing that I would suggest if you really want to do this, the hole was how big? The hole was 4.5. Why is it 4.5? Because it's for an M4 fastener. So you'd go look up an M4 fastener and figure out what is the head of an M4 fastener. So you'd say M4 socket head dimension. And then maybe under images really quick, you honestly just go to a website, but hey, look, we could probably find it right here. Okay, so if I look here, let's view this thing. So if I were to look right here, I find an M4 and I'm looking for dimension D, 6.78. So that actually wasn't terribly too bad. I was thinking, oh gosh, I'm going to cut this out, but that was good. So you go find this. At least we can go, yeah, I kind of know that 6.78, that's probably going to be plus or minus a little bit, probably normal, right? From a socket head M4. Then knowing what we know now, we look at this and we see that, okay, well, we understand that this groove here is for the head of the fastener, about 7-8 millimeters or so, right? Enough to have clearance for the head of the fastener and the wrench that's going to come down here to try to tighten it. So we need to try to pull in this feature. But this is the point that I want to make about a lot of this, do it again, in order of operations. You really never get it right to begin with, and you have to come back and you have to make a change. So what I could do is I could come back to this pad here. I could edit this and I could start pulling these in a little bit until it looks like it gets to where it needs to be. But that's the bad way to do it. That's a bad way to do it. What I would really like to do, now that I've started to build the model and I got kind of dug into it a little bit and I went to do a thing and then I went, well, wait a minute, what's the purpose of this thing? Oh, it's for this. And that means then that this needs to be this dimension, shape, this far away, or whatever the case may be. Well, inevitably, it feels to me like anything I do now will be, anything I do to this shape right now will be a band-aid. And what I need to do is fix it from the get-go to make it be right. And what I mean is this fillet that we added right here and that corner that's right there, we need this element here to be somehow relative to this circle. What would be really great now that we're here is that maybe this thing was just a square. Then we just make a circle on, say, the face of this up here that is concentric with these holes here, but the right dimension, and then we pocket it down to that feature. You see kind of what I'm getting to right there? So let's go ahead and do that, except we have another problem, which causes us to have to learn another thing. I want to go here to this shape right here. I want to get to here, and I want to get rid of these lines, and I'm going to turn them to circles, and I'm going to make them concentric to, oh, where's my holes? The holes here, see, we're here over in the timeline, right? In the tree, we're here. The holes are in the future, so I can't see them yet. So what I need to do is either delete a whole lot of stuff or figure out how to change things in the timeline, reorder them. Now, in order to talk about that, well, I can just tell you how to do it. It's going to be something like take this pad right here and you go to reorder, and I'm going to say that it is after, before, or inside a certain feature. Everything that's yellow, I can't put it there, but I can put it after pocket 1, and that's what we need. If I put this feature here after pocket 1, then I'll be able to see the holes. Now, if this wasn't such a simple tree at this point, and we didn't just make it, you might not easily know or remember what thing is dependent upon another. So we have this really great feature that if I want, I can right click on, say, pocket 1 right here, and I can go to parent and children. Parent and children will show me what elements are dependent upon what. So right now you're seeing what are the parents to pocket 1. What is pocket 1 linked to, connected to, based on? And that's hugely important. So if I look here, pad 1, yeah, that's pad 1. Oh, of course, because pad 1 is what made that flange, and that's what I've got the pocket based on the face out there. Sketch 3, oh yeah, so that's sketch, oh yeah, that's my sketch right there. The radius is inside of it, you see? Now, if I want to take this a little bit further, I could go ahead and double click on, say, sketch 3, and then it's kind of hard to work around in here, but it'll show you what are the parents and children of sketch 3. Let's go to a different one. I'll show you pad 2 because we're going to end up moving this around. We'll go to the parent children of that, and we can see that pad 2 is based on sketch 2 And sketch 3 was made from pad 2, and the edge fillets after it. But then if I go into sketch 2, then you can see that sketch 2 was based upon pad 1, edge fillet 1, and some offsets there. So remember that. I don't use it all the time, but it's really important if you do want to see why certain features maybe are giving you errors because it's tied to another thing. You try to delete a feature and 16 other things disappear that you weren't expecting to disappear. Well, it's highly likely that those things were in some fashion connected to the other. So then time to fix. So what I need to have happen is I need this pocket to be before this pad, because this is the pad that has the sketch in it that we want to align with that hole. So what I'm going to do is I'm going to right click on pad 2 and I'm going to go to reorder. Same thing I just showed you a second ago. Then I'm going to say after pocket 1, hit OK, and now it moved. Don't worry about what just happened. It moved pad 2 after pocket 1, but it does an interesting thing. The underline is where you are in history. So it's a marker. So we just rolled back time to where we're back at edge fillet 1. It's kind of a thing that it does when you do this. So you have to remember to right click on the most current item and then come up here and say define in work object. That will move the line forward and there's all your stuff. That thing right there that just happened gets a lot of people. They don't know what's going on. They think they just blew up their model and then they continue building. And then later someday they realize that the timeline's not right. They reset it and now all of a sudden all their parts come back over the top of all their other parts. So now though, let's check this out. So if I go to pad 2, the one that has our kind of rectangular shape on here, if I double click on this, now I can see my holes. So now everything is much, much better. So now I can go here, and what I'm going to do is we're going to bring some lines back a little bit, but I'm going to get rid of them for the time being. Oops. Oh, that's because it's got a formula attached to it. No big deal. Then over here on the side, I almost always do this off to the side. I'm going to make, well here, let's double click it. So we'll just make 4 circles. I'm going to hold down shift and just make a bunch of circles right there. Hit escape to drop the tool. Then I can come over here and say constraint from that to this edge right there. And then you can come up here and you can pick concentric, or you could right click and say concentricity. Either way. I'm kind of still used to right clicking. Oops, didn't get the right menu. Hit your constraint, hit that, get right on the edge there, right click concentricity. Other way you can do it is I can hold down control and pre-select the 2 things and then go to constraint and do concentricity. All right, and the last one. Now we need to dimension these. So that's we already know, right? So this one here, should we go 7? Should it just be a snug fit, or should it be 8? Right? Let's go 7. We'll say 7. Oh, and remember it's a radius, so we have to change this over to diameter. I'm not going to write a parameter or anything for this. I'm just going to leave it be 7. Okay, so that's going to be our circle, but we have to get it connected to these lines over here. So to do that, what we'll do is we could make this be a construction element, and then we'll draw some lines up to it and do an arc around it. We could do some trimming, but I don't think we've done any trimming yet. So let's do that as well. So we'll get our line tool and we'll bring this up here and we'll stick it right to this. Okay. Now, do you want to go right to the edge of it right here? Well, here's kind of the thing. I want this circle to drive the length of this line right here. So you see it moves, right? So it's not actually anchored by any dimension. Don't put one there. So here's what we'll do. I purposely moved it down, and then I go here, and then I pick that just on the edge. You see? Now, what I will do, though, then is I'm going to take that line, grab my constraints, and I'm going to pick this one right here, right-click, I'm going to make it a tangent. See, so that's going to force that line to be tangent with this circle right here, you see? Then I'm going to make it be, I could make it be perpendicular to this line or horizontal or vertical, either way. Let's do a perpendicular. perpendicular. You see? So now that puts a nice little corner. So I know that this, it goes up, it comes straight out, hits that corner right there, and back in. See where we're going with this? Okay, so now that that's done, the next thing we got to do is get in here and trim some of this stuff away. We have a few different features down here. We have break, we have trim, and quick trim. I can tell you the one we want to use is quick trim. Trim and break are kind of for other different things. You might want to test those on your own. That would be for a later video. Trimming excess elements or breaking a line, and it actually doesn't erase one, it leaves two sides. So you can take one line and break it into pieces by an intersecting line. So we just picked the quick trim, and it works probably just as the way you would imagine. It's a eraser tool. So if I come up here, I pick this, it trims it to the limiting elements there. So it works pretty good. So I'm going to double click that to keep it on. We'll erase that, and we'll erase that right there, and we'll erase that. And then we're done. By the way, notice with just our geometrical constraints and a few dimensions, the dimensions on the circles themselves, we're able to fully ISO constrain this entire sketch based upon the curvature, that radius right there. So then we can exit out and then we're going to have some problems. Now, depending upon what you do, you could have more or less problems. I do want to mention this. Red is bad, right? Red looks bad. Well, I want to tell you that red doesn't mean error. It means update. Just kind of letting you know. It's trying to update. Sometimes maybe, especially in the older days if you had a slower computer, as soon as you like make an edit in Sketch and you leave, your part goes red for just a quarter of a second, but then it's fine. You're like, oh, that was weird. It was red for a second. Well, it was updating. It was updating the part with the new information. Right now, it's trying to update, but it's stuck because it's saying something is not working. Now, I can tell you, though, thankfully, the things that are wrong are just these edge fillets, and that's not even a big deal. So what we got a problem with, if you look over in the tree, just learning how to read this, the part body has an error. What part of the part body has an error? Well, it's edge fillet 2. Well, it looks like there's something going on with edge fillet 3, but if you look close, this is a little swirl. That little swirl icon is the update icon. So edge fillet 2 has an error, and because edge fillet 2 is having a problem, edge fillet 3 cannot update. It can't apply the information, you see. So when you get in here, what you see are these yellow dashes, and they're trying to tell you that this is where the fillet used to be. The part that's kind of confusing here is that that edge still exists. So you think, well, what's the problem? Well, whenever you change a feature, like the sketch that we did, we changed it enough to where these edges, yes, they still exist in the same place that we had them before, but they're not somewhere in the background of the database of the CAD software. They're not named the same any longer. So the link that they're to got broken. It's real easy though. You just come by here and you pick all the edges. I'm not picking the yellow, by the way. I'm not trying to dodge it. I'm just saying just know that what I'm picking is the actual edge of the model. So sometimes it might show your yellow features floating out in space because the edge that it was far away. You would pick the new edge to go to. So pick that one, and that one. 3 millimeters will be fine. But then the next one that was waiting to be updated, it has some issues now. But that one we're going to do something different with because that's this fillet in here, which doesn't even exist anymore. We're not even using that. We could delete it here, but we got to delete all the edges. It's easier if you just go here, hit delete on your keyboard, and get rid of it, and we are fine. So it looks like almost nothing changed because that edge fillet happened to be just about the size of what the curve was that we added into the sketch, but all is good now. So if I were to want to maybe check test this out, if you wanted to, I could look at this. I could check the radius right there to see what it is. I could go to a sketch. I could actually model up another fastener and actually try to put it in there. That's a really big benefit, by the way, of assembly, something that is a bit down the road, that you start actually making other parts and bringing them together, and then you can kind of look around at them and measure them and check them for fit. So we're done with that. We're almost done. We're almost done with this device. Only a couple more things to do. The next one will be super simple. We need to go back to here. Let's get back to our drawing. This circle right here, it shows us that it is 38.1 millimeters diameter. It's also 1.6 millimeters tall. So we've got it all right there, right? So 38.1. Click on the face, go right here, make a circle, snap it to the center, bring it out, dimension 38.1, and then we can exit out, move over to the side a little bit, and we will, go here and we'll pad it out 1.6. You see? That's kind of it, you see? Now, if you actually look at the device though, just a thing I always do because I know it exists. You see right here, there's just a tiny little bit of kind of a chamfer or a slope. It's a draft. It's just a little bit of a draft. It could be actually, you could make it a fillet, whatever you want to do here, but there is a little bit of something going on there. So just because, we've done this recently, let's add it to it. You see, so we come in here and then we go back to refine and we'll get to our draft. And so to review our draft, we need the face to draft and a neutral element. We're not going to do any fancy stuff. We're not going to do a parting element or limiting element. We're just going to say draft that face, and then the neutral element will be this. I could use the base down here, but then what's going to happen is, let's make this a little bit bigger here. Let's make it 20. We'll preview. You see the little skirt that's getting drawn out here. The skirt is coming down from the top. The top dimension will remain that 38.1. If I use the lower base of the flange here as the neutral element, it will bend everything inward, and now my dimension will be incorrect on the top. The 38.1 will be a little bit smaller. So actually I think that this might be 30, and let's just hit OK. Let's see how this goes. You see? That looks nice. So now this one is actually a dual shaft motor, so we'll have to do both sides. We could make one shaft and just shoot it all the way through, but I think we'll make each one separately. What we're looking at here is a few different things. So let's kind of zoom this in a little bit here, you see. So we've got this dimension here, 7.5, but we've got this 20 right here, and you see this little notch? Well, this is the kind of the not the keyway per se, but this is where we're going to put an Allen set screw down here to lock a coupler onto the motor. So that's a flat section. So it's saying that flat section is 20 millimeters down, and it's in from the flat side to the other part of the round part of the shaft is 7.5. So that's not the diameter of the shaft. Down here is the actual diameter. So it's an 8 millimeter diameter shaft, and that the top of the shaft is 24 from the base of the flange. Okay, so 8 by 24. So let's go ahead and model that up. Okay, 8. Oh yeah, see this here? No. Come back to here, 24. Okay, and then since we're here, why don't we go ahead and model on that flat bit. So here's how I would probably say do that. We'd go onto the face of the part here, and this is where it could be helpful to turn it off to the side because there gets to be kind of some stuff in your way. Now you can model it on any side you want. You just need to be able to measure from the flat to the side. So what I'll do first is I'll project it forward. I think this is probably the quickest way to do it. Do not, in this case, make it a construction element, okay? So then I'm going to take a line tool and I'm going to bring it from here straight down, and I'm going to get it to be blue because that's going to snap it. In this case, it's horizontal. It's kind of interesting that when you go into sketch, we have this position sketch. If it hit the normal view, it'll flatten out and it'll show you which way it actually is. So at any rate, it's flat. That's what I'm concerned about most. And then I can hit my dimension and I can go here to the other side, bring that out. Now that's 7.5. Do you see? And so now it's all green. It's all locked up, but I got to get rid of this other side. So then this part's pretty cool because CATIA works with projections in kind of a different way from most. A projection is immovable. You can't change it, you can't alter it. And so why did I do this? Because I need to trim it away. Well, what they'll allow you to do is I can take my quick trim tool and I can come over here and I can click the edge of this and, well, not delete it. If you look what happened, the circle still exists. I'm not modifying the diameter or the shape of the original circle. I'm just saying the projection that I have over here, just don't show some of it. And so now I have just this sliver that I need that I can now exit out of here. and pocket it down. Pick that. And I don't know why it's up to plane, but we'll go dimension, we'll change it to 20 the way that it said, and there is the little notch in the end of the drive shaft. Okay, so let's roll this around. We'll go to the back side here and we'll do it one more time. So pick this, pick that, make it be 8, pad it up, 24, and then check, because it's not always the case, but make sure you check to see, does the other side actually have the notch in it? You can't quite see it here, but they're calling it out. They're saying that it does exist. They're not giving us kind of really a depth on it, so feel free to do what you want here. But this is only 15 millimeters sticking out the back, actually, so we got to fix that. So we'll just edit our pad. We'll say that that's 15. We'll go into the face. Do the same thing again. So here again is what I did. Zoom in here, pick this, project it, click away. Now draw your line tool, again wherever you want it to be, bring it down like that, dimension that 7.5 from the edge. Now it went crooked because I didn't pay attention to how I was snapping it, so I can right click and I can say, you see the horizontal axes right there? Don't worry, it's kind of rotated around again. So I flip it there, it's horizontal, vertical, whatever, it's parallel. And now I can erase the side that I don't need. I'll have that again, and I can exit sketch and then pocket that down. Do I want to do it all the way down, or do I want to leave a little bit like we did on the other one? If we want to kind of make it like the other one, I guess you could make it be 12. I don't know. I kind of don't like the look of that. Yeah, 14. Okay. So, basically done, right? So there is our stepper motor, but we might want to clean this up just a little bit more. Certain faces have fillets, other ones don't in real life. Almost everything gets a little bit of an edge on it except for like machined faces. So I would consider this front face to be machined. If I want this to mate up with another flat face, I don't want to see a little bit of seam left behind because I filleted this edge, okay? But I might want to do it on here or specifically up to here. So right here, your call there. It would not be a big fillet if you did it, right? Let's look at the part. Let's see what we see in real life, because it's probably not going to be in this type of a drawing here. But if I actually look at it and I kind of look around, actually, if you look right here, there's a little bit of a chamfer on there. So that's a chamfer, not so much of a radius. So we can put that in, and then let's click around. You see back here, there's a little radius there. And is there one there? You see, is it sharp looking? Well, it's not quite sharp. If there's any hesitation, that's probably because it's been deburred a little bit and it's not a sparklingly sharp edge. So if you want to add that in there, that's cool. So here's a different concept. Are you making this for a different type of 3D environment, as in a rendered environment? Am I bringing this in to say Blender, one of the stretchy pulley, sculpey modeling type tools, that you want to skin this and texture this so that you could show off the finished CNC like it's sitting inside of a shop somewhere? Well, then maybe if the part has certain looks to it because it's been handled or deburred, then sure, go ahead and add it. If it's for the shop, then maybe you don't do that. Maybe it's a different type of presentation that you want to have. Now this one here, I will say I'll go ahead and add a fillet on the back here because it's going to look nice. So let's go with, we want it to look nice also, right? We've way above served our purpose for making a shape that will serve as a spacer so that we could build, let's say, the frame for a conveyor belt. We could have actually just made it a block. We didn't even need to put all this stuff in here, right? We just needed it to know that we just needed to know that we had the right amount of spacing. What should I make this? Preview 3. I think 3 is a little bit much. Probably more like 2 or 1.5. 1.5 looks good. So that looks probably about the way it normally would be. And the ones down here, if there are any fillets whatsoever, I would say that they're probably like 0.5 or less. So let's whip these around. But like I said, we're going for looks. We want it to make it look kind of nice. So we'll go 0.5. Yeah, see, just a tiny, tiny, tiny touch of a fillet. How about down into here? Should I put a little fillet in here? Probably not, because a fillet is going to screw up the head of the fastener. The head of the fastener, this flat right here, this bit of land right here is for the fastener head to sit on, and if there's a fillet in this corner, it's going to sit crooked. It's going to be weird. So we're not going to add it there. All right. Other than that, I think we're good to go. I think that is our part. So then we can come down here, we can go to view. If you want to look at it a little bit nicer view, now is the time you would probably go to shading to take a look at it and see if everything looks nice. Now, if you forgot to fillet some edges, because again, we wanted to deburr some things or show it in that respect, I can go shading with edges, but without smooth edges. And so it'll show me everything that's sharp. And I could look around and go, oh no, that's good. I wanted these sharp, I wanted those sharp, I wanted these smooth. That's sharp because that's a machine surface. Yep, looks good, right? But we didn't, I forgot a couple things. We were gonna do a little bit of a chamfer on here, right? We did want to put a chamfer there. So we could add that, super small, right? So this here is more like, again, a 0.5, tiny little chamfer. Honestly, I don't think it belongs. I don't think, you know, I kind of see it in there, but this falls in my rule about a machine face. There is also a chamfer up here, a little bit of a chamfer going on that edge. Again, probably really small, something like that. And then the same over on the other side. Don't, whatever you do, put a fillet here, because remember, this isn't really connected to this. This would normally be assembly. And then I guess maybe if we want to do one last piece of somewhat kind of interesting thing, again, this is not an assembly, but we could change colors of things. If you want to change the color of the whole body, you can go to here, and I could say, well, this is a stepper motor, let's make it black. I can tell you that black is going to be probably too dark. You know, you could look at that and say, ooh, that's neat, but it kind of makes it kind of hard to see. What you can do is you can modify the colors a little bit. Go here, more colors. We could apply colors. I've already had that color from before, but you know, pick a gray color, say that's pretty good, hit OK, OK, and then look at it and say, is that all right? Now we still see the dark lines because we've got our view with shading with edges on again. So we go back to just shading and say, okay, sure, that's fine. Now, if you want to continue to do more things, you could do things like, let's change the color of the pad, but then you'd have to change the color of the edge, the chamfer as well, and then this pocket right there. You'd have to change all of those. So here's the thing I want to point out about this, because we like looks. Oh, by the way, if you want to go for, you know, full-on look, hide the axis system there, hide the planes, and then you can look at it. But what I want to mention is this is, again, this is a technical design program. You can go into different types of rendering workbenches in CATIA. We can change the colors. We can do some stuff with it, but it's not about the graphic capabilities of this, the way it looks. So if you hear me or anybody else talk about things like Blender or Maya, any of the other types of modeling software out there where I say stretch and pull, like you can do sculpting in there, those have texture abilities. And so what we would do here, if I want to sell this product, I want to show it, you know, shining on the street, in the car, in the shop, wherever, I would bring this and all my product into one of those other softwares, and then I would texture this. I would skin it, so to speak. You would spend all day long applying different, not just different colors, but you'll get in here. Do you see like the white right here? Because it has this light that's reflecting on it that we just assume is there, right? You would get into here and right on these edges, just like you see the light. I'm not talking, by the way, about light in this example. You would get into here and I could actually do a thing where I could paint just edges with something like abrasion or rust, because over time that's what happened to it. It got kind of worn. This face, there's kind of a cap on the end here, right about here and right up there, and it's aluminum, and it's been handled. It's been kind of brushed, but not really to be, you know, nice looking. So it has kind of a modeled brush looking aluminum. You would add that onto it. The steel shafts right here, they would be the right color and specular, the shine, and such. So that's why, don't get too upset if you can't make something look very pretty here. It's about its accuracy, right? And so then we can take it to shop and make it. But we can absolutely export this as an STL file, a step file, whatever you need, and get it into those other softwares, okay? So then that's it. We did a lot of stuff in this one, but all the things that we've done already before, pads and pockets. We did our fillets, of course. We got a little draft here. We used chamfer a touch, a lot of different constraint tools, projections, and different ways to use things inside of Sketch so that we end up with things like this curvature in here for the fastener head. So a good first real-life practical lab. Do this again on your own, do it multiple different times, and try different ways to go about building it.